Good evening, everyone. So, last class we have completed the fourth unit, no? So, today we'll see the fifth unit, that is about the transport layer. Okay. So, that is it is a layer which is existing above the network layer. Okay. It is actually the fourth layer in the OSI model. So, first we will see the physical layer. After that, we'll see data link layer. After that, we will see the network layer. After that is the transport layer. Okay. So in this transport layer, so today our main focus is on the topic called process to process delivery. Actually, this process to process delivery uses the many protocols. Among that, we will study today the UDP protocol and the TCP protocol, and we try to complete the UDP protocol today. So usually there are each layer in the OSI model altogether there are 7 layers. All the 7 layers have all the 7 layers have their own responsibilities. So in the last class we have seen network layer. It has the different responsibilities providing mapping of IP address to logical address. All that we have seen. So today we'll see what are the responsibility of transport layer. So it is the main first responsibility is segmentation. Okay, so whenever the transport layer, above the transport layer in the OSI model, there will be presentation layer. Right, so this presentation, session, application, all they are grouped together and they are named as application layer. So the whatever the data coming from the upper layer to this transport layer, so that data will be divided into the large data. So the data will be short length data or large length data. That data will be divided into smaller portions. That each portion is called segment. This is called the segments, and these segments have the data called sequence number. Each segment is given one number that is called sequence number, and here in the transport layer the another number is also going to play very important role, that is called port number. Okay, overall whatever the data coming into the transport layer which may be containing a large amount of data, that data will be divided into segments. So that segments is given some number that is called sequence number, and also there is a concept of port number in the transport layer. You will come to know clear what is the concept of port number in the transport layer. So after that, so the second responsibility is the flow control. So what is a flow control means, you see whenever there is a transmitter and receiver are source and destination. So we call it as source and destination. Okay, so for example, source, if you consider client, for example, client, and destination is your sorry. So to consider anything, so server is the source and destination is the client. Okay, so here client requests some thing from the server. So and the server will reply for that. Will send the reply for that, right? So whatever there is some capacity for the client and some capacity for the server. That means so the speed. If it is 100 mega bytes per second, 100 Mbps, and it is 1 Mbps. So this speed must be matched. Okay, so this speed of the source and destination must be matched so that there is no loss of the frames, or there is no loss of the data in the whatever the data is transmitted. If there is no speed matching is there, so at that time there will be some loss of information will happen. So that is all taken care with the in the transport layer. That is a flow control mechanism will be there. There will be control flow of the data. So that all responsibilities will taken here in the transport layer. And the third responsibility is the error control. So these error control we also have seen in the data link layer. In the data link layer we have seen usage of the Hamming codes, CRC codes for error detection and correction. So here also the error control mechanisms or that kind of responsibilities were taken care. So these error control will use the ARQ protocol. So that is automatic repeat request protocol, and as well as we use the checksum for the error control mechanism. So the last responsibility, very important responsibility, that is a process to process delivery. So what is this process to process delivery? For example, process here we should understand. So you have the computer system. So you have the computer system. The computer system is connected to a number of applications. So you see, you will be opening some the Outlook mail. So your Outlook mail. as well as you will be processing some other, you will be also opening some YouTube, as well as you will also be opening some other applications in your computer system. All these each application is called as a process. So each application is called as a process. So whatever the application is there, that each application is called process, and each process is given some port number, that some predefined numbers will be there for each process. For example, if you are sending some mail, that is given some port number, that is a fixed port number. It is also called universal port number for that is hypertext transfer protocol or mail transfer protocol. For different processes, there will be some predefined or pre-assigned port number will be there. So whenever you request some kind of information or some kind of process for that particular application, so that kind of request will be processed to that particular port only. Okay, so that is called process to process delivery. So you see here in the next slide. So when we come across the data in the computer network system, so the data will be, whenever the data is passing from higher layer to lower layer, it is having different forms of names, different terminologies it is going to have. So in the first three layers, that is from topmost three layers, the name, the terminology of the data is data only. So it is in the form of actual. This data you can consider. So the data may be, okay, ఈ డేటా ఏమైండొచ్చంటే దట్ ఈస్ దిస్ డేటా క్యాన్ బి టెక్స్ట్ డేటా, సో దిస్ డేటా క్యాన్ బి ఆడియో డేటా, or this data can be video data, any kind of data it could have, it could be. So that kind of data up to session layer it will be same, but in the transport layer that data is it is named as segments. Okay, I said that whenever data comes, it is divided into smaller segments. That is when transport layer, the data is called as segments. So whenever that data reaches the network layer, so in the network layer, that the data is called as packets. So in the packets, you will have the IP addresses, MAC addresses, as well as the data. You can see in the network layer, you will have the data, you will have the IP address, and also you will have the MAC address. So wherever in the transport layer, so we will have the data, so we will have the so the one more header will be there, so that header is called a segment address. So similarly, when the data comes to the data link layer, that packet, that whatever data we get, that is called frames. In the data link layer, you will have the data and the MAC address. So in the physical layer, it is purely in the binary form. The data will be converted into purely a binary form, that is zeros and ones. So like this, in different layers, the terminology of the data will vary. So depending on the header, what it is adding. So in the transport layer, it will add the header, which is called segment address. And in the network layer, it will add the IP address. In the data link layer, it will add the data packet will be added with the MAC address. So you can see in the transport layer, so you can see the data, the transport layer, the data, it is having the header. This header, it is the complete thing, we call it as a segment. Segment is nothing but the data along with the header. So this header contains the sequence number and the port number. All that details will be present in this header. So next we will see what is the concept of process to process delivery. So the data link layer, as I said, it is responsible for delivery of the frames between two neighboring nodes. So as we have seen, data link layer, the main function is, it is about the delivery of frames between two neighboring nodes over a link. This is called node to node delivery. In the data link layer, node to node delivery happens. Similarly, in the network layer, so you will call it as a host to host delivery. Between the two computer systems, you will have the IP address for each computer system when it is connected to the internet, right? So when it is connected to the internet, it is having the IP address. So that we call it as a host to host delivery. So similarly, in the transport layer, so it is responsible for the delivery of the packet. We call the data as a packet. So this packet, so it is having the port number, all that things. So we call that as a process to process delivery. So we call this as a process to process delivery. Whenever the communication happens in the transport layer, so that we call it as a process to process delivery. The communication in the network layer, it is a host to host delivery, and in the data link layer, the communication we call it as a node to node delivery. So we can see here the clear picture of what is a host to host delivery, process to process delivery, and node to node delivery. Here in this picture we have two computer systems. Okay, so here you can assume that one is a source and other one is a destination, like that, and these computer systems are connected through the router to the internet, right? Okay, whenever there is some transmission or communication between these two devices, so you'll see that the computer system, as I said, it is having number of processes to be running. It will request for the process, and that process, the communication happens, that we call it as a process to process delivery. This happens in the transport layer. Wherever if you consider the computer system, so that is called at the network layer, it is called host to host delivery. And similarly, if you consider at the data link layer, it is called node to node delivery. So depending on the layer where the communication is, or a transmission, or the it is happening, so that is called that is named as node to node delivery, host to host delivery, process to process delivery. So if it is in the transport layer, then what is the kind of communication or transmission is occurring, means it is process to process delivery. So please understand that process is nothing but whatever you are operating in your mobile phones, like you are opening your WhatsApp, that is one process. You are sending some mail, that is one process, right? So you are opening your messages, so that is one process. That each process will have some port addresses. Okay, so that predefined some port addresses will be there. So that is called process to process delivery. So the transport layer will take care of that process to process delivery. So here in the transport layer, one more important point, it is operated. So I hope you understood in the process to process delivery. So what is the layer responsible for this? The layer responsible for this is transport layer. So the very important point in the transport layer, so the two processes communicate in a client to server relationship. Here we consider two devices or two systems. So one can act as a source device, the other can act as a client. Okay, so on this principle, the process to process delivery will happen. So what is a client to server paradigm? Means it is nothing but it is between two devices. Client is nothing but as you know, process, it is on the local host. So every device on the local host is called a client. And what is a server? Means a process, it is on remote host. So that is providing some services. So whatever you will request, so that services will be provided through the server. So that is called the remote host. So usually the transport layer will function based on client to server request, as a client to server relationship. So both the processes, whatever we consider client and server, have the same name. So that means same name here means, for example, day and time. So when a client is requesting something, so the day and time of the communication will be same. So now we are having online communication. So the time here, it is some time. So the same time will be having in the destination place also. So here also same thing, the client, whatever day time it is maintaining, the same time will be maintained in the server, say whatever day. So that means the transparency will be there. So that is called have the same name. That is the meaning of same name. The date and time, that will be same in the client and server. So for communication, we must define. So in the transport layer, we must define what is the local host, local process, and all that things. What is a local server? All that things we have to define. So and also we have to define addressing. So you know, in OSI model, different layers are there. In different layers, the concept of address is going to be different. That means in each layer, a new addresses will be added. So for example, in data link layer, so so in the data link layer, the data packet, whatever we have data packet, it is added with one address called MAC address. This MAC address, where it is provided, can anybody tell me where it is provided? MAC address, it is provided in every device. It is a network interface card of every device will have the unique MAC address, right? So this address will be added to the data in the data link layer. Similarly, when we go at the network layer, when we go to the network layer, a new address will be added to the same thing. So along with the data portion MAC address, so to that the IP address will be added. So this IP address will be added at the network layer. Similarly, in the transport layer, very important, today we are talking about transport layer. So in the transport layer, we can see that port numbers, as we have seen, that data will be large amount of data will be divided into smaller segments. These smaller segments will have the sequence number as well as the port number. Port number here specifically represents what kind of application you are going to access, or what kind of application you are going to use, whether you are sending the mail, or you are watching the video, or whether you are watching the listening the music. So all this specifically they have some predefined pre-assigned port numbers. So that kind of data, that kind of information will be filled in the transport layer. So that is called port number, to choose among the multiple processes. You know that the system, whatever you have, it will have multiple applications, multiple processes running on it. So each application or each process, so it is having some pre-assigned port number, that is called multiple processes running on the host. So that kind of information will be filled, or that kind of information will be provided in the transport layer. Similarly, in the so overall, so now we will focus what are that port numbers, how many port numbers, and all those things. So in the internet model, so in the internet model, usually these are very important concept. It is in the transport layer. So the port number, it is of 16 bits. So 16 bits means 2 power 16 port numbers you can create, right? Among the 2 power 16, so that means that range of the port numbers will be 0 to 65,535. So many port numbers you can create with 16 bits. So among that, so it is very clearly differentiated. So that is IANA. So this is mainly responsible. This is authority mainly responsible for the assigning of the port numbers. So universal port number. You can see from 0 to, so you can see 0 to 1025. So among these all values, 0 to 1023 values are, they are fixed. So that means these values are already pre-assigned for some purposes. Okay. So for example, here I have written. So here you can see. So among these all port numbers, so from 0 to 1025, these values are fixed values. That means these values, that means if I want to use port number 2, you cannot use, because it is already fixed for some other purposes, or for some other applications. So you cannot use the values which are existing in this range. These values are called universal port numbers. So these are pre-assigned as per IANA authority. So for example, so on that port number 80, you can observe here, there are few examples I've written. Port number 80, it is, you cannot use this, because this port number 80, it is already pre-assigned for hypertext transfer protocol, because some applications you are browsing, so you will see the HTTP, so that is having the pre-assigned port number. In the back end, it will be having some port number called 80. So always whenever port number 80 is there, you should understand that it is belonging to the process called HTTP. Similarly, Telnet has a port number, the pre-assigned port number 23. So these port numbers cannot be changed because it is fixed. So for SMTP, Simple Mail Transfer Protocol, whenever you are sending the mail, whenever you are processing with mail applications, so that particular port number will take, so that 25. Similarly, the SSH has a port number 22, FTP has the port number 21. So whenever you are sending some mails, which is the port responsible for that? So I said, in the computer system, so you will be having many applications, right? So you are accessing the mail, you are sending the mail, so all that. You are using some web browsing applications. So what is the port number? So that is 80. So whenever you access the internet, so the internet will send the information, so it will first check the port number. So if you are if you are browsing some applications that related to HTTP, so then definitely it will send that request, that will serve that request to the port number 80 only. So if you are sending or receiving some mails, it is all possible with the port number 25. So like that, the server or the source, server or the client will recognize what kind of process so that is requesting or running, so based on the port number. Even though you are opening multiple processes, multiple applications in your computer system, so each process will be served reliability in a reliable manner, so depending on the identification of port numbers. Okay, so next 102 1024 to 4915 number, these port numbers are reserved for future. So they are not at all assigned for any other, they are not pre-assigned, but they are not in use also, but they are reserved for future use. For example, if you are developing some new application or some new app or some new process, so you can check that application or you can verify that application by using these port numbers. So these are for reserved, they are not pre-assigned. So remaining port numbers, that is from 4000, so 65,535, so these port numbers are used for private. So did you get understand what is the importance of port number in a transport layer? So whenever we talk about process, obviously the port number should come into picture. Every process will have some predefined port number. So according to that, so the server will serve your application. So here you can see some example. So here process to process delivery is happening. So in the process to process delivery, which address is responsive, the addressing will happen in terms of port number. So each process will have some predefined port number. So you can see if you consider this application, so obviously the client and server, so they will have the same day and time. So whatever the day and time is present, the same time, the same day will be maintained in the server also. So for example, this is having some port number 52000, so this is having some port number 13, so that will be served. You can see the data, the destination port number and the source port number. Similarly here also it is having the data, that is the destination port number and the source port number. So this is the source port number. So like this, the port numbers of source and destination will be added to the data in the process to process delivery process. This will happen in the transport layer. Remember, in the transport layer, source port number and destination port number will be added to the data packet. So here there is one more example to make you understand what is the importance of the port number. So here as you see, there is a one device or one system or one station, so with some IP address. This is some IP address. So this IP address is there, means obviously it will be having some internet connection like that. So this station will be running so many processes. So each process will have some port number, so that this process, for example, it is having the port number 13. So this port number 13 will be requesting some, will be performing some functions, right? Some process it will be having. So this transport layer, what it will do means it will assign the port number. It will consider the port number and it will also consider the IP number, and it will form the transport layer header. So now you can observe that transport layer header. So you can see here in this figure, so the IP address and the port number, so the combination of that is called the socket address. Very important in the transport layer, what address you will come across means we come across the socket address. So the transport layer along with the data, actual data, so it will have the IP address, also it will have the port number. So this combination of the port number and IP address, this is called socket address. Socket address. So very important, the socket address is nothing but port number as well as IP number. Here specifically port number represents the what type of process you are running or you are accessing or you are requesting. Okay. So that is the importance of port number in the transport layer. So you can see here the clear picture. So how the port numbers are divided, and which authority is responsible for the division of the port numbers, that is IANA. So this IANA you can observe, so it is the abbreviation for Internet Assigned Number Authority. This is the authority which is responsible for the division of the port numbers. It is divided such a way that 0 to 1024 they are reserved. So they are not they are pre-assigned, right? Pre-assigned, and that is pre-assigned means they are controlled by the IANA, and the remaining, the next coming 1024 to 49,151, so these are not assigned or not controlled by IANA because they are reserved for from future use. Remaining the last coming portion, that is the 49,152 to 65,535, these port numbers, they are for private use. So that means they will be keep on changing. So depending on our requirement, we can change them. That is, they are called dynamic ports, whereas these are called well-known ports or pre-assigned. You can see these are registered or reserved. The last portion is called dynamic ports. In this way, the IANA has divided the port numbers depending on the three portions, that is reserved portion. So this is reserved portion, this is a pre-assigned portion, and this is called private portion or dynamic portion. Very important. So we completed what is a socket address. In the transport layer, the socket address plays a very important role. It contains the IP address as well as the port number. So in the process to process delivery, what is going to, so that is a multiplexing and demultiplexing is also very important, because you see the process, so when you consider some source station, it will be running so many applications, right? So all these applications are multiplexed and they are sent to the server, right? So they are sent to the destination. In the destination, all these applications, they are demultiplexed. They are again divided. That means they all multiply, whatever the multiple processes, you can have several processes. All these processes will be sending the packets, right? So in the transport layer, we call the data as a packet. Packet is nothing but it contains a portion. The data will be there, the port number will be there, as well as the IP address will also be there. This we call it as a packet. So that all several processes send the packets, and all these packets, they are combined. So that is called multiplexing. That is, many to one relationship will be there in case of multiplexing. And similarly, in the receiver side, what will happen in the receiver side? Demultiplexing will happen, right? It is a common thing. So whenever multiplexing happens, the demultiplexing will happen at the receiver side. In the receiver side, what will happen? So whatever the processor which are combined in the multiplexing, they are again separated. After separating, they again done with error checking, and whenever there is error, the particular packet will be dropped. So depending on the header value, all the things will happen in the demultiplexing. So you can see this is the picture for multiplexing and demultiplexing. You see the computer system will be having so many processes, multiple processes. All the processes are combined, that is called multiplexing. So again, depending on the IP address and the port number, so they will be demultiplexed in the receiver side. So in this process transport layer, we have protocols depending on the connectionless and connection oriented service. What is connectionless? So the connectionless means there is no handshaking signals will be there. So for example, if you are sending some mail, so you will get the acknowledgement that the mail is sent, right? That kind of intimation will be there. That will happen in the connection oriented service, whereas in connectionless, the such kind of information will not be there. For example, you are watching the any videos, you will not you no need to acknowledge that. So you are watching that videos, all that, right? So that means in mainly in connectionless service, no acknowledgement will be there. So in connectionless, there is no acknowledgement. Concept of acknowledgement will not be there. Simply the packets will be sent from source to destination. Okay, so for this kind of services, what is a protocol responsible for that kind of service means UDP protocol. So it is a protocol, it is used for connectionless kind of services. Similarly, for connection oriented service, for connection oriented means virtually, physically there won't be any connection, but virtually you will create some connections through the handshaking signals. So what is the handshaking signal means? Requesting. So you will send the request message for sending the for accessing some information. After that, you will get the data. After getting the data, you will acknowledge that you got the data. So the such kind of handshaking signals will be coming in the connection oriented service. So for that, what are the protocol responsible for connection oriented service means TCP protocol and STP protocol. So transfer control protocol and STP protocol, these are the examples for connection oriented protocols, whereas this UDP is the protocol, it is used for connectionless. For example, so your online conference. It doesn't need any acknowledgement. Simply the packets will be forwarded from source to destination. సో సోర్స్ నుంచి డెస్టినేషన్కి సింపుల్గా ప్యాకెట్స్ అనేవి ఫార్వర్డ్ అవుతూ ఉంటాయి. సో అక్నాలెడ్జ్మెంట్ ప్యాకెట్ ఫార్వర్డ్ అయ్యిందా, సో అలాంటి అక్నాలెడ్జ్మెంట్స్ అనేవి ఏమీ ఉండవు అనమాట. So that kind of things will be using the UDP protocol. Whereas some applications where you need acknowledgements, for example, you send a mail, you will get the acknowledgement that mail is sent. So such kind of applications will be running in the TCP and SCTP protocols. These are called connection oriented protocols. So that means virtually you can see in connection oriented, virtually some connection will be established. So between the sender and the receiver through the handshaking signals. So again there is one more parameter we have to understand in the transport layer, that is reliable and unreliable. So we have seen two services, that is TCP, SCTP. This is called connectionless. This is called connection oriented, right? Connection oriented. So connection oriented means physically there won't be connection, but virtually you will create connections through the handshaking signals. Connection oriented. Whereas unreliable communication, that is UDP. So this is the unreliable service because it doesn't have the acknowledgement, whereas this have the acknowledgement. That is why it is slower. And it is also more complex only because complex involves, because it needs some handshaking signals, acknowledgements, all these things will happen here. That is why it is slower. So due to the presence of handshaking signals, it is more reliable also. Okay, the error occurring possibility is very less in case of the connection oriented services. Whereas in unreliable services, so it is usually the flow and error control mechanism. So it is compared to the previous one, so it is very less, but it is very fast also. So this unreliable service, it is very fast, that is UDP is very fast because it doesn't have any handshaking signals or connection oriented services. That kind of things are absent in UDP. So that is why it is very fast also. So it is a very fast. STP and these are very slow. So depending on our requirement, if it is very small length of data, we can prefer the UDP. So but if you wherever we require more accuracy, so there we require the TCP and SCTP protocol. So there we call it as reliable services. The other one, it is called UDP. So where we need so less amount of, so where the much accuracy is not preferred, so that time you can prefer the UDP protocol. So even though it is less reliable, UDP is very less reliable, right? Compared to the TCP and SCTP, the UDP is not more reliable, it is less reliable, but still we use it because sometimes if we want to have fast communication, so that purpose we will use this the UDP. So you can see, do we need reliability control at the transport layer? Even the data link layer is reliable and has the flow and error control. Yes, the data link layer is also providing the flow and error control. So in the network layer, the internet is unreliable. So we need to implement reliability at the transport layer also. So next one we will see error control. Here the error control in the transport layer, it will occur using the concept of checksum. So here we are not going to discuss the concept of checksum. In the transport layer, so we will, so you can observe in this figure, so this is the TCP IP protocol suite. So it is having the 5 layers. You can see 5 layers. This application, it is a combination of the session layer, presentation layer and the application layer. All 3 layers put together. So in the TCP IP protocol suite, that is called application layer. After the transport layer, network layer, data link layer and physical layer. In each layer there is some functionality. So we are focusing more on transport layer today. So this transport layer mainly concerned about the, that is reliable transmission, unreliable transmission, and this is also SCTP, this is a reliable service. So all these are services provided in the transport layer, that is UDP protocol, TCP protocol and SCTP protocol. So this is a user datagram protocol and this is a transfer control protocol. SCTP is a it is a control protocol, control transfer protocol. Okay, so these are the main 3 protocols used in the transport layer. So usually these two are the connection oriented and this is the connectionless service. UDP is the connectionless service. So we try to cover the UDP today. So in the UDP protocol, so as we have already discussed, UDP is a connectionless service. So since it is connectionless, we can say it is unreliable because there is no acknowledgement after transmitting the packet. So in this UDP, we are going to discuss what are the ports, what are the well-known ports for UDP, and what is the user datagram, and what is checksum, what is the UDP operation, and what is the applications of, or what are the uses of UDP. So where that UDP is used, you can see here online gaming. Whenever you are using the process called online gaming, so there the protocol will come into picture, that is UDP, as well as in online conference. So there all you can see the UDP protocol. So but where you see the TCP protocol means there is some acknowledgements, there is some data, so data will be maintained in the TCP protocol, whereas the UDP doesn't maintain any data. Okay, past is past. It is will not worry about the past. Only it will provide the packets. It will just send the packets from source to destination. Wherever it will have some storage, buffering will be there. Some storage will be there in the TCP. For example, your online shopping, you will have a cart. Cart will be filled with all your desired items. So that is, it will maintain some data. So that is called TCP protocol. So in TCP, usually the interaction will be there. You can see in the TCP, the interaction will be there. So in the form of handshaking signals. So in UDP, as I said, so whatever the transport layer we have, the port number, it is of how many bits? Can anybody tell me what is the number of bits in the port number? 16 bits. So 16 bits are there, therefore you can form 0 to some 65,000, some so many number of port numbers you can form. Among that, some port number 0 to, you can have some predefined, pre-assigned port numbers will be there. So among that, there are some port numbers here they have given. So among that you can observe, so the NTP, so it is a network time protocol. So this is having the pre-assigned port number 123. Similarly, your so boot P, you can see this one, boot P, it is having the pre-assigned port number, that is 67. Similarly, remote procedure call, this is having the port number 111. SNMP, that is Simple Network Management Protocol. So this is having the pre-assigned port number, that is 162. So like this, certain range, that is from 0 to I think 1 to, so here it is given. So 0 to 1023, right? Yes. 0 to 1023. So all these values are used for some functionalities. So a few of that are mentioned here. So this is for UDP, that is well-known ports used in the UDP, or I can also write it as pre-assigned port numbers. Pre-assigned port numbers. So what is the datagram? Information present in the UDP protocol. So this UDP protocol carries the information of data. Right, data will be there. Along with the data, some header will be there. This header is having the 8 bytes. The length of the header is 8 bytes. Okay, so like 2 bytes, you can see here you have 2 bytes. So what the information is present in the header means, the header will carry the information of source port number, destination port number, you can see destination port number, and total length, that is 16 bits, and checksum also. This checksum is for error correction, right? So all these information will be put in the header. Understood? This header will contain source port number, destination port number. You know that port number is of how many bits? It is 16 bits, right? Depending on the process, so it will have some pre-assigned port number, which is of length 16 bits. So the length of that port is 16 bits. Similarly, destination port, that port length is also 16 bits, and checksum. So this checksum will tell whether there is any error is there or not there. So that is also 16 bits. All this information, that is source port number, destination port number, and total length, at last checksum, all this information will be accommodated in the header. So this header, it is of 8 bytes. So you can see user datagram protocol. So it is having the pseudo header for checksum calculation. So there is some process for calculating the checksum. So we will discuss that process later, how to calculate the checksum, all that. And we will see what are the UDP operations. Okay, as we have seen, UDP is one of the connectionless service. Okay, it doesn't have any connection. That means there is no handshaking signals will be there. That is, UDP will provide connectionless service, that each datagram will be sent by the UDP in an independent datagram. Okay, so that means there is no particular sequence. That, for example, see, this is the order of the sequence of the source, and the destination will receive the packets may not be in sequence. So this is because it is connectionless service. So here also the flow and error control, you can observe here there is no flow control. So what is the meaning of no flow control? As I said, so when the data here in the UDP service, the sequence number is not going to have much impact, because so it is 1, 2, 3. So if this is the source packets, at destination, so the destination may receive the packet, so it may receive the second packet first, after that it may receive the first packet, after that it may receive the third packet. That means there is no proper order is maintained, proper sequence is maintained. That means no flow control will be there in the UDP protocol. But there will be, because there is no window mechanism, like we have seen automatic repeat request to go back in ARQ. Such kind of protocols will not be occurring in the UDP operation. Only simply it will forward the packets whatever it is getting, so without the knowledge of the sequence. So, and also there is no error control mechanism, but only for it have the error control mechanism called checksum. So this is only one important error control mechanism which is present in the transport layer, but there is no flow control. And also encapsulation and decapsulation will occur with the addition of the port numbers to the IP datagram. So as well as there will be the UDP operation. So this UDP operation will also have the queuing concept also. So whenever you have 2-3 processes, whenever you have the 2-3 services, so each process will be served, right? So you can see there are steps in the queuing. At client side, when a process starts, it requires a port number. Every time whenever there is a process, there will be assigning some port number. So depending on the process you are requesting, it will be assigning some port number through the request. It will request the server or it will request the operating system. Whenever the system is there, so if it wants to send the mail, so it will request the operating system to assign some port number for that. The operating system will know for sending the mail what is a pre-assigned port number. So it will give that port number. So depending on the port number, it will so whatever the service is required, that will be performed. So UDP removes the messages one by one, and after adding the header, delivers them to the IP packet. So whenever you know that in the transport layer, the header will be added. This header will have the source port number, destination port number. So all these port numbers, whenever so they reach, this will happen at the transport layer. Whenever they reach the network layer, these source port number, destination port number, they will be removed and they will be sent to the network layer. So that is the meaning of this sentence. So that means the messages will be removed and deliver them to the IP, that is network layer. An outgoing queue can overflow. Sometimes the queue can overflow. No, that means when number of processes are more, it may happen that the OS can ask the client process to wait before sending any more messages. So when there are multiple processes you are assigning, so the OS will send some request to the client saying that, so don't assign more, that is to wait for certain time, so before sending any more messages. Like that kind of things will happen in the UDP operation, that is control over the queue. So that is called queue can overflow. So when a message arrives for a client, so you can see when a message arrives for a client, so whenever, so you have requested the port number 20, you may think that some application it is used, some process will have. So whenever the client receives that particular application or particular process to be done, so whether it has to assign for this port number, this port number, this port number, so that will be decided depending on the port number. So that is the meaning of this one. So whenever the message arrives for a client, the UDP checks to see if an incoming queue has been created for that port number. So whenever the message comes here, so is this message belongs to this process, this process, this process. So that is decided based on the port number given for each process. So that all thing will happen in the UDP operation. It will maintain the queue. It will also avoid the overflow by sending by making the client to wait for some period of time. After that, whenever the message comes to the client, so it will check the destination port number. So if it is 20, it will go to here. So like that, everything will happen in the UDP operations. So the same thing, the queuing mechanism will also take place at the server side also. So whatever we have seen at the client side, the same thing will happen at server side also. So when the server it starts running, so server asks for incoming and outgoing queues using it well-known ports. Ports are very important. Port numbers are very important. According to the port numbers only, the server will serve the purpose. So when a message arrives for a server, so it will receive the message according to the port number. So port numbers are specified so that the destinations will be clear. So where that particular message should be sent, so that all will be present in the port number. Here also there is a queue. The UDP sends the receiver using datagram to the end of the queue. So when a server wants to respond to client, it sends the message to the outgoing queue using the source port and port number and specified to the request. So port numbers are used to send the messages to the outgoing queue. So UDP removes the messages one by one. After adding the UDP header, delivers them to the IP. So remember, whenever the packet, so the data, so from the data, from the transport layer goes to the network layer, the UDP, this protocol is very responsible to remove the port numbers. Whatever the data will be added in the transport layer, the UDP will be removing all that extra data. What is the extra data added in the transport layer? That is a port number values, destination port number, source port number. All these values will be removed whenever it is sent to the network layer. Okay, so that all become the operations of the UDP. So this is a queuing of the UDP. So diagram. So in the client and server, the day and time will always be same. So client requests something. So all the requests will have some port numbers. This is a process. Each process will have the port number. So all that port numbers that will be sent to the server. So according to the queuing method, so they will be sent, and the server will recognize the port number of the source. So what is the service to be done? So according to that, so it will provide the services. So it will provide the services whenever it is getting the client is getting the messages. So the messages will be delivered according to the port number. So this will also happen in the queuing fashion. So one by one, queuing is nothing but the process. Each process will be served one by one. So these are some operations in the UDP. So among these, I would suggest you to concentrate more on this user datagram. That is, what is this header contains and what is the length of source port number, destination port number. So all these matters in the UDP protocol, and also what are the operations of the UDP protocol. So it will it is not having the flow control, and error control is having only checksum method, and encapsulation will be there, decapsulation will be there. So these all happens with the port numbers. It is one of the connectionless, that is why it is unreliable. And also there is a queuing method. So whenever message comes in, it will always check the destination port number. After that only it will allow the particular message into the client side. So here overall in the transport layer, the port numbers will be added to the data. So that completes the today's topic. So thank you. So next class we will see the TCP protocol.